Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. Welcome back to Exploring Lyra. In this episode we will be taking a closer look at the animations to see if we can get a better grasp of how the animations are working. I got a comment from a viewer that mentioned that there was something called thread safe animations, which sounded really cool. So let's see if we can figure out how this works, or at least get a better understanding of it. So we want to find our animations. Good place to start would probably be characters. I tend to find animations through my characters. So if we go in here and we filter on blueprints, we will get all the blueprints, and hopefully we have some characters here. So we have some simple hero, a queen, a manny, a hero default, a character default, and a tin plate. Let's open up the one that's called manny, I guess, and see what we find. Okay, we see the mesh component has the ABP mannequin copy pose AnimBP, which will just copy the pose across the invisible driving mesh component since the skeletons are directly compatible. If you change the mesh to something incompatible, use retarget AnimBP instead, which targets the correct skeleton. Okay, let's see what it's talking about here. So we have, here we can see our anim class, which is copy pose. Let's take a look in its folder structure. Okay, so here we can see the retarget that it mentioned, and we also have something called base. These seem to be the ones that we have available. Base seems to be a good place to start. Let's open that one up. What do we have here? Anim BP tour number 3. The anim graph does not reference any animations directly. It instead provides entry points to montages and linked animation layers. The graph's main purpose is to blend those entry points together, blending upper and lower body poses together, for example. This approach allows us to only load animations when they are needed. For example, a weapon will hold references to the required montages and linked animation layers. Okay, well, first off here, it seems like we have missed a part because we have ended up on number 3 here. Let's assume that there's a number 1 as well. So if we search for AnimBP tour, we can find number 1 over here. Okay, so what does it say? Also see APB item anim layers base. This anim blueprint does not run any logic in the event graph. Logic in the event graph is processed on the game thread. Every tick, the event graph for each anim blueprint must run one after the other in sequence, which can be a performance bottleneck. For this project, we instead used the new blueprint thread safe update animation, and that's the one that the viewer talked about. Found in the My Blueprint tab, logic under blueprint thread safe animation. Can be run in parallel for multiple anim BPs simultaneously, removing the overhead for game thread. For the overhead on the game thread. Okay, so here we go. Blueprint thread safe update animation is what it's referring to. Okay, so it's a function. Okay, okay, so if we, so the event graph is completely empty because we have everything in here. Okay, let me just open up a regular UE5 project and show you how it normally looks. Okay, we're back. So this is just a third-person template, a basic one that's created, and let's find our character. And let's find its animation blueprint and see what I was talking about. So we go to the mesh, we go to the queen animation, and the queen animation says this is a child anime blueprint, child of APB manny. Okay, so this one, we go to the parent. All right, so yeah, here. So this is what the comment was talking about. And normally here we will be getting our owning actor, and we're getting information from it and storing it in information on this event update, essentially, that's running normally, and which is apparently running on the game thread. And the new method, which is over here, which is running in the function called thread safe update animation. We apparently do this differently. This function is primarily responsible for gathering game data and processing it into useful information for selecting and driving animations. A caveat with thread safe functions is that we can't directly access data from game objects like we can in the event graph. This is because other threads will be running at the same time and they will be changing the data. Instead, we use property access system to access data. The property access system will copy the data automatically when it is safe. Here's an example where we access the pawn owner's location, search for property access for the context menu. Okay, so it seems like the benefit of having the thread safe update seems to be that we can offload some of the logic from the game thread, which means we get better performance. The offshoot or the downside to it is that we have to have information gathered passively, sort of whenever the threads deem it safe to do so. So what do we do here then? We have try get pawn or get actor location, which is a property access from the context menu. So we go and type in property access, get a variable. Okay, and here we get the ability. All right, so here we can essentially bind like we would normally do. So we could get like try get pawn owner and get control rotation or is controlled or whatever we want to find out essentially. And if we do that, the variable is updated, and this is now a thread safe passive updating of, or at least getting of this information. Okay. And what we're doing here, we have a bunch of functions called updates, and we're setting some variables. Okay, let's take a look at these updates and see what they're all about. Let's start with the first one. So we have an update location data here. We seem to be getting some data from actor location. We're doing some comparisons and calculations and setting some parameters. Okay. Let's check the next one. Okay, so this one seems to be handling rotation data then. Okay, so if I'm understanding this correctly, we're essentially just using this to update all the stuff that we're interested in and have categorized different functions for the different types of data that we want to gather. And I'm going to assume that all of these parameters that we're setting are actually going to be used by the animation blueprints later down the line. Okay, that seems straightforward enough. So where do we go from here then? If we have blah blah blah. Right, we encountered number 3 earlier, didn't we? We found it in... Was it the event graph maybe? No. Anim graph? Oh, there we go. Okay, so this anim graph does not reference any animations directly. It instead provides entry points for montages and linked animation layers to play poses at certain points in the graph. This graph's main purpose is to blend those entry points together, like upper and lower body, and this approach allows us to only load animations when they're needed. For example, a weapon will hold references for the required montages and linked animation layers, so that data will only be loaded when the weapon is loaded. Weapon instance shotgun holds references to montages and linked animation layers. That data will only be loaded when B weapon instance shotgun is loaded. B weapon instance base is responsible for linking animation layers for weapons. Okay, so we have a bunch of different, we're storing some, we're caching some, we have some state machines seeming to do some things, and we're caching some of them and we're using them later. We're doing additives and we're layering, blending, and we're caching some more. Okay, we're rotating a bit, we're running it into control rig, and then we're getting an output pose. Okay, so we have some some fairly advanced things going on here, but let's take a look at this weapon instance base that they're mentioning. So we'll go to the all folder. Weapon instance base, was it? Okay, so this blueprint over here. And this blueprint is, let's see, we have ended up in an activate anim layer and play paired animation. That sounds pretty much like what we were looking for. Let's see if we can find an event graph and see how this works. Okay, so we have two events. We have an on-equip and on-unequip. And they are running a macro each, and there's also determination done here. So let's see what we're doing here. So when we equip the weapon, we get the pawn, we get a specific component called Lyra pawn character parts. We're setting it. And if it's valid, we are getting combined tags from it with this prefix as a requirement. And then we get a result, which is a gameplay tag container structure. So we get a bunch of tags back from this. And once we've done that, we're going into this macro. And we have a weapon equip montage here. So since this was, as they mentioned here, a base class and shotgun would be like a child of that, then this is just a placeholder for the shotgun to have a weapon equip montage. So the shotgun will have an equip montage essentially to play whenever it is equipped, and a different weapon like I don't know, a laser rifle would have a laser rifle equip montage and such. So we're going into the macro, and what are we doing here? We are we have the montage. First we are checking what is the best anim layer. So we send in the tag container that we got earlier, and from that we will be getting a class of the anim instance. So we're getting an animation blueprint class here. And if it is valid, we're going to link that class to our skeletal mesh component. So we're sending in that information to our skeletal mesh that this is our animation blueprint that we're going to be using. And then we're playing a montage of... Okay, so the equip montage that we saw sending in earlier. So that's what we're doing. So we're just doing the equipping, and then we're sending out some out information here. And we have essentially set that we're going to be using a specific weapon then. So let's see what kind of weapons we have. So if we go to the base and we use the reference viewer, let's see what we get here, like so. So here we have the weapon base, and from the left we can see everything that uses it. So we have a gameplay ability melee, we have some heal pickup, we have a weapon instance for net shooter, one for pistol, one for rifle, one for shotgun. Okay, so these are our 4 weapons, it seems like. So let's go to one of them, like the shotgun here. So we have the shotgun, let's right click and edit, which should open up the blueprint. There we go. Okay, so it's a completely empty blueprint. It doesn't have anything in it except for the information in the config. So if we open up it, okay, we can't get the collapsed. Okay, so it's over here now then. So this is the properties that we have. So we have an equip montage, we have an unequip montage, we have an attack montage. We seem to be having some layers here. So we have, okay, here we have actually animation blueprints. We have a feminine one which requires the tag of cosmetic anim. Let's see if we can get some more space and see what that says. Okay, so if we have the animation style for feminine, so meaning the feminine bot or character, then we will be using that blueprint apparently. Otherwise we use... No, this one also says... Okay, so this is for the equip and that's for the unequip. Okay, so we have a default layer here. So this is the default layer if we are not playing the feminine one. Right, so let's go check out that blueprint, I guess. So we have APB shotgun animation layers. That's not what I clicked, was it? It was? Okay. So let's open that one up. Okay. This looks fairly empty, however we seem to have, this is something that's parent or a child of something, so let's see what kind of values we're inheriting. Okay, so we have some anim structs cardinal direction. We have some actual animation sequences. We have an array of animation sequences, so probably like a bunch of different idle animations that it randomizes between. So it seems like this is the one that is actually containing all the animations that it talked about earlier. Where was that? It was in the base here. Yes, it's saying it holds references to montages. So this anim layer animation blueprint holds all the animations for this specific weapon, essentially, which we determine to use when we're sending it in here into the link animation class layers then, when we determine we have picked up a weapon. Okay, that's straightforward enough, I guess. Let's take a look at its parent, I guess, and see what we find there. Okay, this one looks similar. Everything looks pretty much the same as the other one. Parent. This also has a parent. Item anim layers base. Let's go check that one out, I guess. Okay, now some things are happening here. Now we have some differences here. So we have a state here for can play idle break. So we're essentially doing the same thing here as we did in the thread save function. We're getting things passively to determine certain conditions. Let's go check the event graph. Okay, so we have some stuff here. Anim BP tour 5, wasn't the last one 3? Was it the base? So we seem to have missed some step in between here. Let's see if we can find that first before going back here. So anim BP tour and 5 and 6 and 9. Let's just do a full scan. So let's see, we're looking for 4. We have 1, 3, 2, 4 over here. So we are now currently in the animation blueprint mannequin base. So the same one we were in before, where number 3 was, but we are now instead in a locomotion state. So essentially in the anim graph over here we had number 3, and inside of locomotion state here is where we have comment number 4. Okay, so let's see. This state machine handles the transitions between high-level character states. The behavior of each state is mostly handled by the layers of the animation blueprint item anim layers base, which is the one that we actually came from, that we had gotten to before. It was here where we actually found number 5, which we got from which was the parent from the rifle and the shotgun. Okay, so here we have the states. We went in here before actually, so we saw these states earlier. And what we have here, this is an example of a state alias. State aliases help to reduce the amount of transition lines required. This alias allows multiple states to transition between jump and the same condition, without having to explicitly transition lines from each source state. Yeah, so to explain aliases a bit then. So this symbol over here, you can see like sort of a half arrow to both sides. That symbolizes a state that is a alias. And an alias is, it has a property here. You can see a bunch of checkboxes. You will get a line for each of the other states that is available in the state machine. And each of the checkboxes that you check in for an alias is essentially saying that this state is the same as that one. So if we were to find something like idle is over here. So idle and jump sources is essentially the same, this state says. That means that if you are in idle and this transition here, which we happen to have one which is an automatic one it seems, then you would transition from, despite being in idle, you end up in jump selector because they are considered the same. And equally, it also has a start state, so you can be over here, and you could theoretically be here as well. So it can transition differently. We have more aliases here as well. So we have a bunch of them, like this one is also the same as cycle. Essentially, by doing this, you can reduce the complexity of having arrows between different allowed states and sort of decouple them a little bit. I hope that makes sense at least. All right, so we have found that part, so that's all good and fine. Let's go back to our item anim layer base. Number 5, as with anim BP mannequin base, this animation blueprint performs its logic in blueprint thread safe update animation. Also, this animation blueprint can access data from animation blueprint mannequin base using property access and get the get main anim BP thread safe function, as example below. Number 6, this animation blueprint was authored to handle the logic of common weapon types like rifles and pistols. If custom logic is needed, like a weapon like a bow, a different anim BP could be authored that implements the all item ani layer interface. Rather than referencing animation assets directly, this animation blueprint has a set of variables that can be overridden by child animation blueprints. These variables can be found in the anim set X categories in the My Blueprint tab. So those are all the variables that we saw that were overridden in rifle and shotgun. This allows us to reuse the same logic for multiple weapons without referencing and thus loading the animation content for each weapon in one anim BP. See the APB rifle anim layers for an example of a child animation blueprint that provides values for each anim set variable. So we saw this in the shotgun, so we're aware of this already. So now the question becomes, this is empty. What is the next step here? We're in the event graph. Let's check the anim graph. The anim graph is empty. We have some layers. What are these? Okay, so let's try and find which one were we actually on. Where we were on number 6. So let's find number 7. Number 7 is over here. We are now in, okay, we're still in this same animation blueprint, but we're now in a state called full body idle state. And it says this animation blueprint implements a layer for each state in anim BP mannequin base. Layers can play a single animation or contain complex logic like state machines. Okay, so we have something called idle SM here. And if we go to the mannequin base, full body idle state. Okay, so the connection here is that in a state, in the state machine, like idle in this case, instead of setting up an animation or a blend space or anything like that, you send in a linked animation layer graph, which has the same name, full body idle state, as defined here in the animation blueprint. And in here we then have a state machine of itself. So this, let's see if we can explain this. So this state has a state machine in it, which is this full body idle state, which has this state machine in it. Turn in place number 6. Okay, apparently there's even more guided references, comments that we can look through. We will just keep this to the tour one, I guess, because otherwise this will be very, very long. But essentially here we seem to have like a state where we're idle, and this is how we can transition to our idle breaks, and possibly also turn in place and recover and then go back to idle again, essentially. Unless we actually end up in a situation where we're transitioning from the idle state and then interrupt whatever we're currently doing over here then. Okay, so that's how we do that. So we could find that one in animation layer. Is this the one? Idle body state? Yeah, this is the one. Okay, so we have one over here then. So that's that one. So where did our number 8 go then? Number 8 is over here. We are still in the same animation blueprint, but now we're in full body start state. So full body, so this one over here. And what do we say here? This is an example use case of anim mode functions. Anim node functions can be used to run, sorry, I'm reading this wrong. Anim node functions can be run on animation nodes. They will only run when the node is active, which allows us to localize logic to specific nodes or states. In this case, an anim node function selects an animation to play when the node becomes relevant. Another anim node function manages the play rate of the animation. So we have a situation here where we have a sequence evaluator, which evaluates a specific animation at a single specified frame, and it has a on-relevant condition apparently, where it's a function like setup start animation, and on update it will run a update start animation, and we can probably find these as well by going here. And here we can see a bunch of the variables I think we set earlier in the thread safe where we started actually. So it's coming round back to this then. So here determinations are being made of how to proceed in the animation blueprint. And then we're using that to, in this case, layer between that one and another evaluator. And number 10, did we miss something? Number 8. Let's find number 9 and see what that one says. Number 9 is over here. Still in the same animation blueprint. We are now in the update start anim. Was that... No, that was not one of the ones I was in, I think. Ah, I see. So if we go back to, what was it? Full body idle state. No, full body start state. So the update start anim over here is... Okay, so that's where this is. So this is the one that executes when it finds itself relevant, I guess. It says, this is an example of using distance matching to ensure that the distance traveled by the start animation matches the distance traveled by the pawn owner. This thus prevents foot sliding by keeping the animation and the motion model in sync. This effectively controls the play rate of the start animation. We clamp the effective play rate to prevent the animation from playing too slowly or too quickly. If the effective play rate is clamped, we will still see some sliding. To fix this, we will use stride warping later to adjust the pose to correct the remaining difference. The animation locomotion library plugin is required to have access to distance matching functions. Okay. So it's doing some fancy things to make the animation smoother, essentially, based on things that it has calculated before, and things like what it's getting right here now, which is displacement since last update and such. Okay, let's go back to our, was it in the full body state? Number 10. What do we have here? This is an example of warping the authored pose of the animation to match what the pawn owner is actually doing. Orientation warping will rotate the lower body to the pose to align the direction the pawn owner is moving. We only author forward, back, left, right directions and rely on warping to fill the gaps. Orientation warping will realign the upper body so that the character continues to aim where the camera is looking. Stride warping will shorten or lengthen the stride of the legs where the authored speed of the animation doesn't match the actual speed of the pawn owner. The animation warping plugin is required to have access to these nodes. Okay, so that's what it's doing here. It's smoothing out the animation when it comes to both the movement forward and also when it comes to the rotation before outputting the pose. Okay, so that's number 10. Do we have an 11 as well? 1, 3, 5, 2, 5, 6, 9, 7, 8, 10. Okay, so that seems to be the end of that trail, essentially. Wow, okay, so clearly there's a lot to this. Hopefully this helped you a little bit better to understand how things are working together by the different animation blueprints that we traversed and how the weapons are actually equipping them on the skeletal mesh essentially, and then having their individual montages loaded in their individual animation blueprints so that they only load those when they're relevant, and then have some pretty fancy and advanced state machine logic when it comes to handling all the information that we stored in the beginning. It is a very advanced animation blueprint for sure. Hopefully you got some knowledge from it. Worst case, you at least hopefully got some idea of how you can navigate and try to delve in to get more information yourself, like I did in this case. Anyway, take care. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.